Okay, so we are leaving off, or picking up where we left off on the second half of 6-7. This is very quick, as you see we don't even have a full page left. So solving radical inequalities. I'm going to do the same thing as I did before, walking you guys through what the steps are as we work on this first problem. Okay, so first step. First step is kind of a specific instance. It starts with if the index is even. If the index is even, meaning if you're taking a square root or if you're taking a fourth root, you have to worry about this step. If it's a cube root or something else, you don't have to worry about this step. Identify where the radicand is non-negative. Okay, so if the index is even, identify where the radicand is non-negative. So we're going to look at example A. So the first thing that we have to do is take a look at this 2x plus 2. Since it's a square root, meaning the index is 2, so the index is even, we have to figure out where that 2x plus 2 is going to be non-negative. Because remember, with square roots, we're not allowed to plug anything that would be negative, because we aren't allowed to take square roots of negative numbers. Or I guess the square roots of negative numbers won't be real, and we're only talking about real numbers here. So we want to know, first of all, where is this 2x plus 2 going to be greater than or equal to 0, which is what we mean by non-negative. Non-negative is different than positive, because it includes 0. Okay, so we're going to start with that. So we are going to subtract the 2 from both sides. Okay, so we get this. Then we're going to divide both sides by 2. Okay, so this is saying that as long as we plug in something that's greater than a -1, we won't have any issues underneath the square root. As long as we plug in something that's greater than or equal to a -1, we will only be plugging non-negative things into the radicand. All right, then step 2, solve the inequality algebraically. Solve the inequality algebraically, meaning we go through this, we do whatever we need to get the x by itself. So we get the radical sign by itself, we square both sides, everything like that. Okay, so here we're going to start by subtracting 1 from both sides, because we know we need to isolate the radical part. We learned that when we were doing just the functions on the previous page. It's greater than or equal to 4. All right, let me kind of block this part off here. Okay, then what we're going to do to get rid of the square root is we are going to square both sides of the inequality. Okay, so when we square the left-hand side, it cancels out the square root, and we just have 2x plus 2. It's greater than or equal to, and then when we square the right-hand side, 4 squared gives us 16. Okay, then subtract this 2 from both sides. That's what we mean by solving this algebraically. We're just doing whatever algebraic moves we need to do to get the x by itself. Okay, and then finally we're going to divide both sides by 2. Okay, so we get x is greater than or equal to 7. Okay, so now this part's very important when we are graphing and setting up our final answer. Is we've got x is greater than or equal to 7, and x also has to meet this criteria. Okay, so when we're doing these inequalities, remember doing compound inequalities, we had and inequalities and we had or inequalities. When we're graphing these, they are always and inequalities, because it has to meet this condition in order to even fit the inequality, but it also has to meet this condition in order to make sure that we're only plugging real numbers into the square root and that we're getting real numbers out. So when we say it has to be greater than or equal to -1 and it has to be greater than or equal to 7, it ends up just being this. Because these ones all kind of fit in here. All the numbers that are greater than or equal to 7 are also greater than or equal to -1. So in order to be bigger than 7 and bigger than -1, they just have to be bigger than 7. Okay, so these two kind of combine up, and I end up just with x is greater than or equal to 7. It's kind of like the overlap between the two sets. All right, and so the last step is test values to check your solution. Okay, so we can kind of do that in our heads, and I'll show you a couple of examples. So if you plug in something greater than or equal to 7, it's supposed to make the inequality true. So let's take something like 10. All right, so say we take 10. 2 times 10 is 20, plus 2 is 22. Square root of 22 I don't know what it is. It's going to be somewhere around 5, somewhere close to 5, in between 4 and 5. And then if I add 1, I know it's going to be something greater than or equal to 5. Say I plug in something that's not greater than or equal to 7, like 0. Okay, if I plug in 0, 2 times 0 is 0, plus 2 is 2. Square root of 2, something a little bit bigger than 1. So something a little bit bigger than 1 plus 1 is not greater than or equal to 5. So that third step just kind of means verify to yourself that the solutions actually work. Okay, so we're going to look at another example here. So this one, the index is even. It's an index of 2 because it's a square root. So the first thing that we're going to do is make sure that this thing is non-negative. So set it greater than or equal to 0. Couple algebra moves here, add 4 to both sides. These will cancel. Then I have a 4x is greater than or equal to 4. Divide both sides by 4. Okay, and then we get x is greater than or equal to 1. So this is saying the only things I'm even allowed to plug into my square root are things that are greater than or equal to 1. Because if I plug in anything smaller, then I'll have a non-real answer, because I'll have negatives underneath the square root. Step 2, solve the inequality, algebraically. So again, whatever algebra moves I need to do here. So I'm going to add 2 to both sides. I'm left with the square root piece on the left is less than 4 plus 2, which is 6. Same next move that I did up above, I'm going to square both sides, left and right. When I square the left-hand side, it cancels out the square root, so I just have the 4x minus 4 is less than 6 squared, which is 36. Okay, and then from here, it's no longer radical, it's just a nice little polynomial. So I'm going to add 4 to both sides. Okay, I've got a 4x on the left is less than 36 plus 4, which is 40. Then the last step is I'm going to divide both sides by 4. Okay, so I have just an x on the left-hand side, and this is less than 10, 40 divided by 4. Okay, so remember, the way that we combine these is always with an and inequality. So we're looking for the values that are greater than or equal to 1 and less than 10. So they have to be bigger than this number, but they have to be smaller than this number. So whenever you have to be bigger than one number and smaller than another number, you set it up as a 3-piece inequality. Okay, so it's going to look like this. 1 is less than or equal to x. That's this inequality just flipped around, which is less than 10, and that will be your final answer. Anything smaller than 1, and you won't get a real answer here, and then anything bigger than 10, and it won't fit this inequality. Let me remind you guys of something really quickly if you're trying to figure out how you know you end up with this. Let's graph both of these on the same line and then show you what the and inequality would look like. So here's 0, here's 1, and then all the way down here will be 10. Okay, so I'll graph the first one in green here. So this first one, x is greater than or equal to 1. So greater than or equal to means I have a closed circle, and then I shade over to the right, anything greater than, and then less than 10, I'm going to do this one in pink. You've got an open circle here, and then less than means anything off to the left. Okay, now since we're looking for an and inequality, it needs to fit this green line and this pink line, so it ends up just being the overlap, which is this section right here. Okay, so in between 1 and 10, so bigger than 1, less than 10. This one has the or equal to because this has the or equal to. This one does not because this does not. Okay, just in case we were curious about part A's solution, I will show you that as well. So here's, 0, here's 1, 1, and somewhere down here is 7. So I'll do the first one in green again. Greater than or equal to, oops, I guess we needed a negative one, not a positive one. There we go. Okay, so greater than or equal to negative 1 means greater than or equal to, and then we shade off to the right like this, and greater than or equal to 7. So on the 7, greater than or equal to, and then greater than or equal to also shades off to the right. So if we're looking for the and inequality, we're looking for the overlap between these two, which just happens right here. This is the overlap between green and pink. Okay, so that's just greater than or equal to 7. So if you're ever confused about how the and inequality looks, just graph them both and then see where they physically overlap. Alright, so nice quick video for you, and that's the end of Chapter 7.